Okay, I'm going to solve another lead code, and this is the second time broadcasting, and this is going to be a medium difficulty. The point of broadcasting is that I have to explain to you what I'm doing and how I'm doing. A job interview has a duration of 45 minutes, and let's see if I can solve it. So, the problem is to make the vector fair, in the same that the sum would be fair if removing certain indexes the sum of odd and even numbers are the same, right? I hope you can see it. I know the last time it was difficult to see it, so I'm going to increase a bit the resolution to 125, and I hope now the camera, the broadcast, it's easy. So it's fair if the sum of both values return the number of the index that you could choose such after the removal is fair. Okay, you can now so what is the output? The number of indexes. So not which indexes, but how many have to be removed. And there are hints, but I'm not going to check them. So I'm going to start by checking input nums, and this would be something like return is if nums is an instance of list, although I'm not completely sure that this would work. Well, let's see if this is the case. Oops, sorry. Now it is working. I'm trying to think how I would do it. My intuition is that it would be a tree in which for each or a dynamic programming, so for each value we can not change it or change it. So it would be a backtracking function. So as soon And this looks silly to me because if you remove all the numbers, then it is fair. So you choose exactly one. So if in this one we remove 1, two plus 4 is 6, and that's why it's 1. Okay, fair enough. So we just have to check which one to remove. So the way that I'm going to go is by the easiest way is just to create a function, but it could be a dynamic programming option as well, in which we know the combination up to one point and the rest of it. So I'm going to start with the simplest version and see how it goes. So def is fair, and we assume that inside this inside of this we already know if that is the case. We already have the element removed, so this is going to be something like if length of nums if it's not 0, nums add. And if this is the way to append. So now we have the exact numbers, and even odd equal, we initialize them with zeros, and then for let's for each element for num in nums, position and num in 8 nums, we have a counter. We will call it balance between odd and even. So if if position, if it's 0, then balance num, but if it's not, balance minus equal num. So if it's balance, more checks. I'm not checking this because it's not enough that it's a list, it also has to contain only numbers. So if it's equal to 0, it's even, if not, it's odd. And I'm not even sure if I write even and odd correctly. Odd numbers, yeah, and even. Very good. And that's what it is. So return balance. If it's 0, it is balance, and if it's not 0, it's not balance. So for let's do it for moved number in the range, the length of numbers. So removed index. If we find the removed index, so new this is after one removal. There would be from 0 to, this will be the numbers, from 0 to removed index, it will be 0, from 0 to 0 it would be empty, plus we can remove, plus 1. To the end, and I believe this would remove, although let me do a manual check. So this B, C, D, remove 0, that would be nums the 0 to 0 plus nums from 1, and that would be nothing on B, C, D. If this would be remove 1, 2 to 2 and from 3. So this will be A is 0, B is 1, and that will be it, plus 3, 1, 2, 3, D. So it seems working. So now we do the check if is fair after removal, oops, return the index, which is the removal of the index. And I think we can do it a lot better you cannot make it fair. I'm not sure why this should rise and or give invalid number like -1, but they insist on giving zeros. Now, test set. Now, I will try with the empty, which is not fair, but also with 1, in which case you remove. In which case you remove position 0, 1, 1, 1. Let's not forget the docu code. Check, return the index of removed number that makes the list fair. Let's not forget the complexity, where n is the length of nums and there is nothing else, so time would be n square, because we create a new vector, and the space would be as well, wouldn't be a square because we keep deleting, but it would be linear. I'm very tempted now to test it, so let's test it. Position is not defined. Okay, it seems that I made a spelling mistake. No, I made more than one mistake. Here the problem is that, of course, if you remove the position 0, it is fair. So, instead of this, okay, this is going to look a bit ugly. But this is a way to reverse it. The array I believe. Okay, so I'm going to try something different. So for position, let's start at the end, equal in range of length the numbers -1 to -1, because that's the last position, and the increment would be -1. I'm a bit puzzled because this should be working, but that's okay. Num is num the position inside numbers. Of course, while explaining to the camera, it seems a bit more difficult. This is stupid because I'm modifying the function that just checks. That just check if something is balanced. So I shouldn't be checking that. In reality, what I wanted to change is this. For to start from the end. Until -1. Okay. What I did with position till 17. Oh my god, again. Suppose I have to review how I build this loop, and that's a quite embarrassing mistake. So it starts with 3, 0, 1, 2, 3, and it should be an out of range, because this vector only have 2 positions. Zero, 1, 2. output 3. That's a bit strange because 3 is out of range unless you want to claim that the first position that it starts with 1. Return the number of indexes. Aha, that is the problem. That is the amount of indexes. So now that's a different problem. It's not which index, but how many of them, how many solutions there are. So solutions, we will start with 0 and increase 1 and then return the amount of solutions. And this has an exponential, so I don't think it's a very good job. However, it's already 26 minutes recording. Oh, not valid case. Oh my god. That's embarrassing. Let's try to resubmit. Output 1. I think this is... Aha! Time limit. So I'm going to put a flag here that this took me 27 minutes and try to do it again. But I keep the assert. So what I'm going to do now is dynamic programming for odd numbers and even numbers. So what I'm going to calculate is how many to the right and how many to the left for a given position. So a given index, calculate balance to right and left. Now I'm aware that the balance also change, but that also facilitates because I only have to multiply by -1 one of the balance, and it should get the correct number. So giving an index, calculate. So this would be to the left up to index x excluding x. So left is initialize it as a vector of zeros by the size that we want to create. Now for position. Now, like this algorithm, we calculate the balance. But we are going to do only the position in range, but this time we are going to start in position 1 because we are looking to the previous number, to the length of numbers. So if the position it's even, then left of position equal to the previous position plus the numbers of the previous position. Obviously, we are excluding the current value. I believe this is a plus, although it's not that relevant. And this is a minus. This left has the balance of all up to the index from position 0. And the left is going to be the same, but the other way around. Left, right, right. It's going to be the same, but instead we are starting in -2. Obviously the first position have a 0 because we have a balance of 0. And we have to go up to the first position. Although I have to do some check here. So if we have A, B, C, D, we start this 0, 1, 2, this is 3, 2, 1, 0. So if we start with nums, that would be the length, it will be 4 minus 2, it will be position 2, which is this one here, then 1, then 0, and stop. Because we are only counting in one direction, probably there is no need for this value. No, there is, because that's eliminating this index. So yeah, let's just leave it as it is. Here instead of minus, it will be position +1 because we are filling the numbers in the opposite direction. And I hope it is. And of course it is not right, is the left vector. Probably there is a more elegant way to do this. Nevertheless, I have the two vectors, and now we are going to calculate the balance of vectors. So yeah, we could calculate, but we are not we are only going to use a counter, so there is no need. And what it does, the counter, is if right minus the left equals 0, then solutions increase by 1. And we have to go through all the vector, and in this time return the amount of solutions. Now, this is a bit duplicated and probably it could be better explained. The doc string, I'm going to copy it because I believe it's going to be very similar, except that this time is going to be linear in cost, because this block is linear, this block is linear, and this block is linear as well. This is position, could be called index. Index removed. That's a better one. I think this could probably go here, but let's try before. Oh, syntax error. Line 24. Left if else. I'm not sure why there is a syntax error here. I don't see anything special. Hmm. That's interesting. Uh-huh. Here there is a duplicated bracket. Maybe that's why. 31. This is not so good result. Now you have to forgive me for a second. Okay, I'm back. So it's already 43 minutes and I'm running out of time, so that's not very good. That's not very good. Oops, why I don't have the results. Expected 1. So we are going to try print right, print left. Okay, to the right. Is this the right vector? So if we remove the 4, there is nothing to the left. If we remove 6, this looks wrong. Let me check again. Okay, let's look to the left. So to the left, if we remove the position 2, which is the 0, there is nothing. In this position, to remove anything to the left, there is 2, so that is very correct. If we remove 6, is q minus 1 looks correct, and if we remove 4 there is minus 7. So far so good. However, the right doesn't look correct at all. And this is because I made a silly mistake here. How dumb I am. God. Good that it's not a real job interview, because now the special cases that I would try would still be like this. Now I know I'm running out of time, it's already 46 minutes. 46 minus 27 is only 20 minutes, so I guess I've done it in a shorter time, but that's about it. So let's see how it goes, if it's submitted. Happy days, 93% of Python. That's a great success. So is that it? Well, probably it needs more checks. If every number is a number, or if it's something else. This space is unnecessary. I think it's slightly more readable with this space. I guess this makes it slightly more compact. Somehow interesting that we go to the right and then from the right to the left. This was a regrettable mistake, too much copy paste. Alright, I have a checklist. They are in the Snell case, they have meaningful names, they are asserts, 8 cases, big notation, correct formatting of the string. I'm not really sure if this will work, but yeah. I wouldn't write what it returns because it's already written on the top. Return the... No, that's incorrect. Returns how many indexes could be removed, what that will make the vector pair vector. Yes, that is more correct. So that's it for today. Okay, it was 50 minutes, so I guess I have to improve on the timing. Thanks everyone for the confessional debugging, and see you in the next video.